Hey, this week we're going to be working with roots. It's very important that you understand what roots are, what that means, and how we use them. So firstly, let's look at some inverse operations. Inverse operations are the things that undo each other. Things like addition and subtraction, multiplication and division, and exponents and roots. So you can think of roots as kind of the opposite of taking an exponent. So let's look at some terminology real quick. You'll see this symbol, that is the radical. If you see a radical over a number, that number is the radicand. This just means we're taking the root of this number, and this number here is the index. That tells you which root to take. So in this case, we're talking about the third root of 8. This means what number to the third power is going to equal 8. Let's look at some examples. If you just have the radical here, you'll notice that there's no index. If there is no index, it's assumed that this is a 2. It's assumed that this is a square root here. So this is asking for the square root of 16. So this is essentially saying what number squared equals 16. That would be 4. 4 squared is 16, so the square root of 16 is 4. Here's a common mistake. Some people will tell me that the square root of 16 is 4 squared. No, 4 squared is 16. And because 4 squared is 16, the square root of 16 is 4. Do not tell me that this answer is 4 squared. It's just 4. Because 4 squared is 16. So same thing here. If there's no index, we can assume that's a 2. This is the square root. It's asking me what number squared is 36. That would be 6 because 6 times 6 is 36. So we see the index is different here. This is asking us for the third root of 8. That's asking us what number cubed is 8. And that would be 2 because 2 times 2 times 2 is 8. And same thing here. The index could be any number. That's just telling us which root. So we're looking for some number to the fourth power is 16. That would be 2 again, because it's just one more times 2 than 2 cubed. 2 to the fourth is 16. Okay, it works the same way with fractions. You'll notice this is the square root. There's no index, so it's assumed a square root. This is asking us what number times itself is going to be 4/9. Okay. Luckily, we notice that this is a square and this is a square. That means 2/3, because 2/3 times 2/3 is 2 squared over 3 squared is 4/9. So some number squared over some number squared is 4/9. That's 2/3. And it works the same way with variables. This is asking us, you can do these individually, just in the same way that it did 4 and 9 kind of individually here. You can do these individually. So the square root of x squared, the square root of anything squared, since they're inverses, is just itself, because x times x is x squared. So of course this is x. And then this is asking us what number squared is y to the fourth. Well, remember when we're multiplying like bases with exponents, we just add the exponents. So that means y squared times y squared is y to the 2 plus 2 is y to the fourth. So the square root, some number squared, is y to the fourth, then that number is y squared.